right, hopefully you had a chance to finish up assignment 2.1a and go through and do some of those exercises and see how we apply some of the ideas that we talked about yesterday about variables and operations, combining like terms, coefficients, constants, writing things in alphabetical order, and all that sort of stuff. So hopefully you're getting pretty good at that. We're going to pick up where we left off yesterday, and we're going to go through. So here's part 2, and just a reminder, hopefully you can do this without looking at the other set of notes or anything or what we've done before. Remember, like terms have the same variables and the same exponents on those variables. Okay? And we normally write expressions in alphabetical order. If there are exponents, though, we also try and write the answer in a particular way, and that way is called descending order. And when we write things in descending order, that means we write the terms with the biggest or largest exponents first and write the constant at the end. So we'll kind of, whatever the highest exponent is, we'll start with that one, and then one that's maybe a little bit less and stuff like that. And hopefully you'll see what we're talking about here as we go through and do some of these problems. So this is kind of a summary of what we did in the previous discussion. Now let's take a look at a few more examples. I think we've got about 6 examples here. I've got an asterisk by a few of them, so we'll take a good look at those. But let's run through and do this one right here. So we've got 2x, negative 7y, negative 8xy, negative 12x, and negative 2xy. So let's identify some of those like terms. Now remember, this is kind of a general rule of thumb. There's no good way to write it if we've got more than one variable. I kind of like doing this one first, so I'm going to grab those ugly guys and get those out of the way first. So we've got negative 8xy minus 2xy, so using the rules for combining integers, that's negative 10xy. Done with those. Again, I'll lightly cross those off so I can see that I'm finished with those. And then of the terms that are left, I've got x, y, and x. Alphabetically speaking, this one would come next, so the x's would come next. We'll use the rules for combining integers, and lo and behold, let's see what we get here. Different signs, so we're going to find the difference. The difference is negative 10 with an x on it, so we're done with those. And then there's nothing to combine this with, so we just have negative 7y. So I'm going to circle that. I'm going to write or down here. If you wanted to write it this way, that would be okay. But again, I really like this one a little bit better for what we're doing here. There's no hard and fast rule on it. If you really wanted to do it this way, that would be okay. But again, there's no question that the negative 10x would come before the negative 7y. All right, let's take a look at this one, and you'll notice why this one has an asterisk. This one is the first one we've come across that has exponents. Now, just as a quick reminder what this means, if I write 6x squared, that literally means, now notice this is implied multiplication, there's nothing in between there. That literally means 6 times 2 of these guys right here, 2 x's. This is called the base, and that's called the exponent. We may talk about that more later on in the course. Definitely, you know, in later courses you'll deal with those words a lot. But this is literally what it means. It means 6 times 2 x's multiplied together. So our variable is x times x, if you wanted to think of it that way. So same thing here. This would be negative 10 times x, but this is just a short way to write a multiplication problem. That's what an exponent is. So let's run through here and take a look. We have 1, 2, 3, 4, 5, 6 terms. These are definitely like terms, so I'm going to underline those and go ahead and combine those. If we use the rules for integers, this is going to be negative 4x squared. So if I have 6 of these minus 10 of those same thing, I'm going to end up with negative 4 of those things. That doesn't change to x or no x's or anything weird like that. These are still x squareds. Again, if you needed to, you could say if I've got 6 apples minus 10 apples, that would be minus 4 apples. The name of the variable doesn't change. It's still just x squared. So I'm going to lightly cross that off, again, so I can still see the original problem. I notice I have constants. I know I'm going to leave those for the end, so I'm going to underline, put a little square box underneath each one of these. Those are like terms, so if I combine those, let's see those rules for combining integers. Same sign, I'm going to find the sum, so that's going to be negative 9x. Lightly cross that off, and then I've got the constant at the end, and if I put the two of those together I end up with positive 2. So that is the order that we'd want to write these in. And this is where we can really see what descending order is. So as far as there's not really an alphabetical order here because we've got x's first and then we've got the constant at the end like we normally would. But what we've got here is we've got a bigger exponent here than we do right here. In fact, you might want to think for just a second, what would the exponent be on this one? How many x's were used in this multiplication problem? I'm going to change colors and write it in. The exponent would be 1. So you can notice that we have 2 x's multiplied together, just 1 x in that term right here, and then really there wouldn't be any x's on that one right there. So I'm going to go ahead and erase that. But keep that in mind as we go through and look at these. So another couple problems. Let's take a look here. We've got C's, H's, C's and H's, another C, and then a C and an H. Again, sticking with this way that I'd like you to do these, let's go ahead and combine the CH terms. That's going to give us 7CH. Out of C or H, we're definitely going to do the C's first, so I'm going to combine those two terms together. Negative 14C, again just using the rules for combining integers there. And then we've got that term on the end there, that negative 9H. So once you get practiced at this really goes pretty quickly. Again, the only other way that you'd want to write that one would be this, but I'd really like you to write it the way we did up here. Okay, so we'll leave it like that. Take a look at this one here. We've got A's and B's, definitely have another AB term. You might want to think about what the coefficient is right here. Again, if it's not written, it's understood to be a 1, so a positive 1 there. So altogether that's 7AB. Go ahead and cross that off. I've got terms with A's and terms with B's left. Combine those. Again, this is understood to be a 1, so this is going to be negative 5A. Done with those guys. And then again, that is also a 1, so when we put those together, let's see, different signs, find that the difference would be 1 and it would have a negative in front of it, so it'd be negative 1b. Now you might take note here, if we stick with the way we kind of conventionally do this, or the way we normally do these things, we normally don't write the 1 there, so probably the best way to write it would be just like that. Okay, and I'm not going to bother writing that other one since I kind of want you to write it in this order right here. Okay, let's take a look at this next one. Negative 3xyz plus 9xyz minus 7xyz. Now you'll notice that we got lucky on each one of these because they're all in that order, xyz. These are all like terms, so all three of these can be combined. So if we put the two of those together, that's going to be, let's see, positive 6xyz minus 7xyz. Find the difference. The difference would be 1, and the bigger one's negative. So I'm not going to write the 1. I'm just going to write negative xyz. Now, if you wanted to put the 1 in front there, you certainly could, but we kind of get used to the fact that if there's nothing in front, it's assumed to be a 1. So I'd like you to get used to that as well. So we'll write it that way. And then again, we've got another one here with exponents. Both have y's, so we're going to do the two of these together. That's a 1y squared minus 3y squared, so that's negative 2y squared. Done with that one. Let's look at the y terms here. 4 and then another 1, so that's going to be 5y. Again, assumed 1 is the coefficient there. And then we've just got the constant that goes on the end, so we've got negative 3 right there. All right, so that's it for combining like terms. Hopefully that gives you enough that you can get the assignment done and practice this, because you're going to run into this stuff all the time. Thanks.